So yeah, I'm talking about Bitswap in Boost. So could I have a show of hands, people who know what Lotus is? Yeah, got a few people. Okay, so I'm going to talk a little bit about that as well. So basically, what we're trying to do is bridge the IPFS network with the Filecoin network, which is something we've kind of been waiting to do for about 2 years. So we're very excited about this. So I'm going to talk about what is Boost, but first let me talk about Lotus. So Lotus is Protocol Labs reference implementation for a Filecoin node. So Filecoin nodes need to talk to each other to reach consensus on which block should be the next block in the chain. Lotus implements that part, but it also takes care of the storage array. It does mining. It sends something called window post onto chain to prove that it has blocks. And it also used to do data transfer, that is, getting data into Filecoin and out of Filecoin. So last year, we broke off that last piece, the data transfer piece, and we put it in a new binary called Boost. So this makes it a bit easier to manage one of the most complicated pieces of the Filecoin network today. So yeah, I guess I've put here that it's a storage and retrieval front end to Lotus. So at the moment, the way that IPFS talks to Filecoin is a little bit indirect. So we have this thing called an auto-retrieve node. So IPFS connects to the auto-retrieve node over IPFS's native transport protocol called Bitswap. And then auto-retrieve connects to Filecoin over Filecoin's native retrieval protocol called GraphSync. So obviously, there's some inefficiencies there. From translating between the protocols. And it's also, the discovery is a little tricky because the IPFS node has to be connected to auto-retrieve node in order for them to be able to talk to each other. And there's no discovery mechanism. So we introduced a new sidecar to Boost called Booster Bitswap. And Booster Bitswap is essentially just a Bitswap server. So this allows IPFS, instead of going through auto-retrieve and then to Filecoin, it just goes from IPFS directly to Booster Bitswap running on the Filecoin node. So let me talk a little bit about how discovery works. In other words, how does IPFS know where to find stuff that's on Filecoin? So when a Filecoin storage provider receives a storage deal, it receives data. It creates an index of all of the blocks in that data, and it tells an indexing node, hey, I've got all of these blocks. And then when clients want to know where a block is in the network, they just query the indexer. They say, hey, who has this collection of blocks? And the indexer says, oh, these storage providers. So talking specifically about Kubo, in Kubo v0.14, they've added a new protocol called reframe. So traditionally, IPF has found stuff on the network by asking the DHT, the distributed hash table. So with the reframe protocol, we can configure Kubo to instead talk to our indexer. So Kubo queries the indexer. It asks, who has my blocks? Kubo says, these storage providers have the blocks, or these endpoints. And Kubo downloads over Bitswap in parallel from the storage providers. Demo time. All right. Stop praying, everyone. Okay, where's my video? Okay, so this is a video that I uploaded a few days ago. It's about a big bunny. I recommend you watch it. It's pretty fun. And I'm going to give you the CID in a second so you can download it over IPFS. So here's what it looks like. This is the interface that people using Boost see. This is the web interface. So you can see this is a list of downloads that I've done over the last week in our production miner in Bulgaria. And, sorry? Oh yeah, sure. I mean, the text is the same size, but yeah. Yeah, it's just a web interface showing like a list of deals, basically. So at the moment we're having some issues with S3, so not so many successful, but once it sort of shows you the stage that a deal goes through once it gets into Filecoin, like it goes through a data transfer, gets verified, and then goes into the sealing state. Yeah, so here is, so here's the deal that I uploaded a few days ago with my bunny video. And this is the root CID of that deal data. And so I'm now going to download this root CID over IPFS from the production storage provider. So the first question is, how do I find where my CID is? And the answer is I go to the indexer and I paste into this box over here the CID that I want, click on contact, and it tells me, okay, this PID at this address with the Bitswap protocol has that piece of data. And also it's also exposed over the graph sync protocol. So this is automatically done now by the reframe protocol. But essentially what the reframe protocol is doing behind the scenes is it does, I don't know if you can read that, it does an IPFS swarm connect, meaning connects my node on my laptop, my IPFS node, to the IPFS node on our production miner, and then IPFS get. So what you're looking at there is IPFS talking through Bitswap to a storage provider in production for the first time in history. Can we make some noise? So that's going to take a minute or so to download, it looks like. Oh no, I'll wait for it, 10 seconds. Keep clapping, yeah. All right, so let me move that. Yeah, so you can see this is the same video that I uploaded a few days ago. Cool. Okay. So how do we motivate storage providers to actually run Booster Bitswap? So there is a cost for them. They have to, it's a resource cost in terms of actually running the server, and they also have to pay egress costs. So we're currently working on incentivization for storage providers, and that was what the summit was about yesterday, the Retrieval Incentive Summit. But for the time being, we're going to say that anyone who's part of the Evergreen program needs to run Booster Bitswap as a requirement. And storage providers are highly incentivized to do that because they make a bunch of money. So we're expecting Booster Bitswap to be widely available starting Q1 next year. So next steps. So today, Filecoin storage providers can announce a single address on chain. And so any client that wants to talk to a storage provider just has to go and get that one address. And it means that all of our requests have to be proxied through a single node. So we're going to update the protocol so you can add different addresses for different transport protocols. So you can have one for GraphSync, one for Bitswap, etc. And we're going to scale. So what I've shown you today is mostly proofs of concept. It works quite well, but we need to scale out to the kind of load that the internet is going to put on it. And next is for you guys to show us what you got. So we're super excited now that we've connected the IPFS network to the Filecoin network to see what all of you come up with and the exciting things that you're going to be building on top of it. Thank you.